All right. Um Okay, so today we'll be solving the problem which has been asked in the Jest 2012. All the problems which has been asked from the mathematical physics in the Jest 2012. We'll be discussing all these problems. Okay, so the very first problem is that the value of the integral of ln x by x square plus 1 whole square dx. Okay, so in order to find this problem, we can solve this problem using the normal integral method. That is, keep the substitution x equal to tan theta, and then we can find the value. Okay, so this is one method what we have learned in the class 12 standard, but right now as we have done our contour integral, so we can solve this problem using the contour integral method. All right, so in order to solve this problem, you need to have the basic idea about the contour integral. Okay, so in this case we will take a contour which will look like this. Okay, so the contour will look like this. The radius will be taking, and the radius here we need to draw radius. Smaller radius will take this radius is will take a smaller, and this radius, yeah, this is smaller we have taken, and this radius, another radius we need to take, that is from here to here. Okay, and this radius is the capital R will take. All right, so all the radius, the first radius is very small, so we'll take that radius epsilon. Okay, epsilon tends to 0 obviously, and the right radius is capital R. Now the trajectory of the contour is in this way, anti-clockwise, and these anti-clockwise coming from here, then go here, and then coming from the small circle, and then going to here. All right, so we are naming this contour here A, B, okay, and here C, D, and this is origin O, and this contour will be denoting by sigma, and this is basically, that this is real axis and this is complex axis. All right, so now we have to solve this problem. We need to first write down the problem. The problem is integral of, let me write it properly, integral of 0 to infinite, I don't know what is happening, I'm sorry, pardon, 0 to infinite ln x by x square plus 1 whole square dx. In order to solve this problem, we need to take the another contour integral for this with the variable z. Let's take a contour integral of c, that means contour ln z by z square plus 1 whole square dz. All right, so this integral consists of we can see that 4 different integral. At very first it is coming the contour, that is outer radius of the circle. Okay, outer circumference, along the outer circumference of this semicircle. So we are writing sigma, that is ln z by z square plus 1 whole square dz. All right, now the second one is this, that is a to b. All right, so a to b we are writing in terms of this is, if this is radius, so this is plus r, obviously you can see that, and this is minus r. All right, so the radius would be, we can write along AB, A to B, that means this integral will be ln x, because it is along x-axis, obviously you can see that along x-axis, so ln x dx. The very next term will be plus the small circle with the radius epsilon, so we are writing gamma, and gamma is indicating the small circle. Okay, gamma ln z by z square plus 1 whole square dz. And the last one is the integral of CD. You can see that integral of CD, right? CD, and this is basically along, this is along x-axis, so we should write ln x by x square plus 1 whole square dx. Okay, so this is the all the integral we want to find. If I want to find the contour of the along the integral of the ln z square plus 1 dz along the whole contour. All right, so now we'll take some approximation, and from the approximate value few integral will goes to 0. But before that, we need to find out the residue along the Cauchy residue theorem. We need to see, we can see that this function right, fj is this function, right? So ln z by z square plus 1 whole square, this is the function. This function has pole of order 2, so we are writing this function has the pole of order 2. So pole of order 2, right? So if this has pole of order 2, if I want to find the singularity, then singular point would be z square plus 1 equal to 0 or z equal to plus minus I. Okay, so now from the contour integral, you can see that from the diagram plus I is lying inside of the contour. Okay, plus I, but minus I is not lying inside of the contour, so we should forget about the minus I, and we'll only consider the plus I to solve this integration. All right, so now what we need to do, basically we need to find the residue. Okay, so we need to find the residue. What is the residue? The pole of order 2, we know the formula is 1 by n minus 1 factorial ddz of n minus 1 of z minus z naught to the power n into f of z at point z equal to z naught. All right, so here n for our purpose n equal to 2 and z naught equal to plus I. All right, so if I want to find the here, so this is basically 1, it is coming, right? 1 and this ddz of z minus I whole square, fz equal to ln z by z square plus 1. I am writing in this format, z minus I and square and z plus I square whole square, because this is a whole square, we are writing z square plus 1 in terms of z plus I and z minus I. All right, so this term is getting cancelled from both sides, and what we are left with ddz of ln z by z plus I whole square. All right, so you have to find the derivative. What you need to do, okay, so first box this one, because otherwise it will be very confusing for you to understand what is there. Okay, let's take another ink so that it will be very clearly visible that we are doing something and this is separate. Alright, so in this space we will try to solve the derivative. What is the derivative? ln z into z plus I whole square into that is 1 by z, okay, minus 2 into z plus I into what will be there, that is ln z, right? ln z. Okay, so this z plus I whole to the power 4. All right, now if I want to find this, then this will be, what will be the value? Tell me. If I sorry, there will not be any ln z here, z square plus 1, and then yes, this z should not be here, right? Yeah, I was wrong. Yeah, so this is the value. Now we need to go back and plug in the value z equal to z naught. Okay, so what is the value of the z equal to z naught? So you can see that from this equation, if I put the value here I, then 2I, so I am writing I plus I whole square by 1 by I minus 2 into I plus I ln I. Okay, so and in the denominator that will be 2I whole to the power 4. Okay, so this equation will become 2I, that means 4 I square by I, that means I left out, minus what is here, 2I into 2, that means 4I. Now ln I, what is ln I? Basically ln I equal to e to the power pi by I can write that, right? For example, we know that I, that is equal to e to the power pi by 2, right? From where I can write that, because e to the power like 2n plus e to the power n, e to the power odd multiple of pi by 2. So e to the power odd multiple of pi by 2 is basically I, we know that, right? So if I replace this value, if I take logarithm in the both side, obviously, sorry, here would be 1I. So if I take logarithm on the both side, ln I, it will be I pi by 2. Okay, so here ln I is equal to I pi by 2 by 16 I square minus 1 plus 1. Alright, so what we can get from here, if we just take out 4I, we have, and this is basically minus my I square plus, so this will have the 4 into pi by 2 by 16, and this will results as the 2I. If I take out common I, then this is 2I plus pi, right, and by 8. Okay, yeah, I'm right, most likely. 2I by 8. Okay, so this is the value. Okay, so 2I by 8, this is the residue at the point, this is the residue at the point. Okay, residue at the point yes, so this is the residue what we have found at the point of the first singular point. Alright, so first singular point we have found the residue. Now from the Cauchy integral theorem we know that the residue, the integral value, is basically the integral value of fz. Okay, so we know that from the Cauchy residue formula of integral equal to 2 pi I into sum of the residue. So here we have 2I plus pi by 8, so this is the sum of the residue, this is the value of the integral. Now coming back to all the integral we have in this contour integral, we can see that if r equal tends to infinite, okay, so if r tends to infinite, that means the circle, it will become very less, or the integral, or you can in other words you can say that when r become infinite, then this circle will go down and go down, and when it will come down, then the singular point will move outside of the circle. So when the singular point will move outside of the circle, then this value of this integral, this will goes to 0. Okay, and again when epsilon tends to 0, that means when the radius of the inner circle is very small, then again the integral of this gamma, that will again goes to 0. When so we can write that as we can write as r tends to infinite and epsilon tends to 0, then integral of the ln z by integral of ln z by z square plus 1 whole square will left out with the basic integral of a to b, that means minus r to minus epsilon of ln x by x square plus 1 whole square dx, plus the integral of epsilon to r and the ln x by 1 plus x square whole square dx. Now as these two value are goes to 0, so we can write minus infinite to minus epsilon ln x square plus 1 whole square dx plus the that is epsilon to you can write in place of epsilon, you can write also 0, right? So we can write 0 to infinite ln x square plus 1 whole square dx. Now here comes the point. So you can see that for these if I plug in the value of ln x equal to minus 1, okay, let's write x equal to minus x for this integral, for the first integral. For the first integral, if I write x equal to minus x, then this limit will definitely change. This limit will become infinity to 0 and ln minus x then x square plus 1 whole square and dx will be, there will be a minus. Okay, the first integral I am writing. Okay, so this integral will become as there is a minus, so I can change the limit 0 to infinite ln minus x by x square plus 1 whole square dx. Alright, now here you can see that the minus x ln minus x I can write in terms of, like, I want to write in this format, right? So ln x I can write ln of minus x I can write equal to ln of x into minus 1, right? There is no problem. So we can write ln x plus ln of minus 1. Okay, so ln of minus 1, what is the value of the ln of minus 1? Okay, so again come back to here. So ln of minus 1 is basically gives us the value of I into pi. Okay, so 1 is equal to the value of 1 and the minus 1, that is the difference between the ln minus 1 equal to I pi. So this value we are plugging in into ln x plus I pi. Alright, so then we will plug in this value over here. So the total integral, so I am writing again in form of total integral. Okay, so yeah, there is a shortage of space you can see that. So this integral will become that is ln z by z square plus 1 whole square. Contour integral is equal to the 2 of 0 to infinite no, I cannot write 2, so I can only write 0 to infinite ln x plus I pi by x square plus 1 whole square dx plus integral of 0 to infinite ln x plus x square plus 1 whole square dx. Alright, so this is the value we can write. Now in the very next step, what I can write is the value, this value and this value, they are equal, so I can write here as 0 to infinite ln x by x square plus 1 whole square dx, and this is a twice we have, so we are writing 2 plus 0 to infinite I pi, obviously x square plus 1 whole square dx. Alright, so this is the integral we have, and we know the value of this integral. Okay, so from where we know the value of the integral? From the residue theorem we have found out the value of this integral, and this happened to be the value of the integral is this. Okay, so value of the integral we can write in terms of that is what I can write, that is 4 pi I square, 4 pi I square, that means minus 1, right? So minus 4 pi I square plus 2 pi square, right? 2 pi square into I divided by 8. Okay, so this is the value. So if I just separate the real term and the imaginary term, the real term is basically minus pi by 2 and imaginary term I is equal to pi square by 4. Alright, so this is the value of the integral. So we are writing directly, equating the value of the integral in this both side. So the value of the integral, value of the integral is what? Value of the integral is minus pi by 2 plus I pi square by 4. Okay, so as we can see this value, so you can see that this integral, okay, this integral in the left hand side and the right hand side, the second integral is basically imaginary. So if we just equate the real part and imaginary part, so we'll be able to see that the 2 of integral of 0 to infinite ln x by x square plus 1 dx is equal to minus pi by 2. Okay, we are equating real part and separating real part and imaginary part of the integration. So from this equation we can get the value ln x square plus 1 dx is equal to minus pi by 4. So now we need to check whether we have found our answer or not. Minus pi by 4, let's see what is there in the answer. Answer is minus pi by 4, the answer option B, that is correct option. Okay, so this is the calculation what we have done. Okay, first we have found the residue and then we have found the value of the integral, and this is the answer. Okay, so if you can understand, if you cannot understand, just pause the video and rewind every single point, then you will be able to understand. This is very simple integral. This is not very difficult, but yes, you need to practice this type of integral, otherwise you won't be able to solve, because here we have written ln minus 1 equal to I pi. This is one crucial point. Another crucial point is I equal to e to the power I pi by 2 in the version of pi. That is, you need to, if you want to write it in this format, then you need to practice it definitely, so that you will be able to write. Okay, all right, so I am just zooming out once again so that you can see the whole problem once again, and then moving on to the next problem. Okay, so this is the maximum zoom out situation we can do, and you can see the problem here. All right, so we can move on. Right, so now we will try to look at the second problem. We have discussed, we already know what is box function is. So if you have studied quite well in the class 12 standard, then you probably know that box function x is basically the value of x is such that the value it takes only integral value in the limit. Okay, so if the value of x in box function is like 4.2, then the value of the box function should be that is 4. Okay, so if the value of the box function is like minus 1.2, then it will take the value of minus 2. Okay, so the box function has the integral value and it always take the previous value in the number line. All right, so in this case we can see that the x denotes the integer, greatest integer obviously, and if I want to derive this integration, that is x box e to the power minus x dx, then what we need to do, we need to split the integration into few separate part. All right, so first one 0 to 1, then 1 to 2, and then 2 to 3, and then 3 to 4, and so on. Okay, so this is the what we need to write inside, obviously x box e to the power minus x dx. Now if you can see the inside 0 to 1 integration limit, this x has value 0, so we are writing that is 0 to 1 0 e to the power minus x dx plus what you need to write, that is 1 to 2, the value is 1 e to the power minus x dx. This is next one is this is integration of 2 to 3, yeah, that is 2 e to the power minus x dx, and so on. Okay, so if we do the integration, and then what we need to we'll see that this value first term is going to 0. So if the first term is going to 0, the second term will be e to the power minus x, and e to the power minus x 1 into e to the power minus x, that means e to the power 2 minus e to the power 1, right? So we will write that is in terms of upper limit minus lower limit. So 1 e to the power minus 2 upper limit minus e to the power minus 1. Okay, so this is the first integration. Second integration is again 2 into e to the power minus 3 minus e to the power minus 2. Okay, and 3 into e to the power minus 4 minus e to the power minus 3, and so on. Alright, so from this equation we can get that e to the power 1 into e to the power minus 2 and the 2 into e to the power 2 into minus 2 into e to the power minus 2. Okay, and this is minus e to the power 1, and we can see that here minus e to the power 1 we have, so minus e to the power 1, and also we have 2 into e to the power minus 3, and that is 3 into minus 3 into e to the power minus 3, and plus 3 into e to the power minus 4 and minus 4 into e to the power minus 4. If you look closely, then you will be able to see a pattern. Okay, so what is that pattern? So pattern is this, that is basically for minus e to the power minus 1 minus that is, you can see that e to the power minus 2 minus e to the power minus 3 and so on. So this is a GP series of factor of e to the power minus 1. E to the power minus 1 is increasing in every single step. Alright, so if you take out minus as a common factor, so the first term e to the power minus 1 by 1 minus the common factor e to the power minus 1, right? So this equation will be minus of divide with e to the power minus 1 by e to the power minus 1 division we are doing, so e to the minus 1. So this is basically 1 by 1 minus e, that is answer. 1 by e minus 1. Is there anything wrong with what I have done here? Mistake what I have made, that is basically when e to the power minus x integration, there would be a minus sign, no? So there would be a minus sign, so there will be a bunch of minus sign, and this is minus 1, this is plus 1, so this is minus 1, this is plus 1, this is minus 1, this is plus 1. So end of the day what we are getting, and that is all the 2 value e to the power minus 2, this will be plus, and the e to the power minus value, this will be the first value, this will be plus, second value 2 into e to the power minus 3, this will be plus. Okay, this will be plus, and this will be minus. Okay, 2 into the minus 3 and 3 into the minus 3, this will be plus. Okay, and again this 3, this will be minus. Okay, this will be minus here, and this will be plus. So end of the day what we are getting, all the values there should be plus. What I have done, why I have done the mistake, because minus x is there, no? So integration should have one minus sign, so that's what we have done the mistake, and the e to the power, this minus sign is no longer we need, and this will become plus. So the answer is this. Okay, so the answer is 1 by e to the power minus 1. So that is the answer, and if that is the answer, then the answer will be this one, option number A. Alright, so you are understanding my point, I guess. Okay, so we have done the second problem of the Jest. Okay, so if you know this exam, you know that the question is not that very easy, that is there are lots of chances are there to make the mistake. So likewise, just I have done a mistake, so there are lots of chances are there to make a mistake. Okay, now moving on to the next problem. This problem, all right, so moving on to the next problem, problem number 3. So in this problem I can see that the infinite series is given, and if you don't know this series, then it will be really difficult for you to solve. So as I know the series, that is, this is basically tan inverse x series, where we know that x minus x cubed by 3 factorial, no 3 plus x to the power 5 by 5 minus x to the power 7 by 7. So we need to do that convergence or the divergence test, because this question come most likely I can remember this series converges to. Okay, so if we place x equal to 1, then that will be tan inverse 1 equal to 1 minus x cubed by 3, 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, and so on. So this series tan inverse 1, we know that tan inverse 1 is equal to pi by 4. So this series converges to the value of the pi by 4. That was is basically a convergence test. So if you know the series, then this will be very easy for you. Otherwise you need to do using the complex analysis and find out the value of the convergence, or it is diverging. So you need to do the convergence test. But if you know the value of this series, then it will be really helpful for you to go and write down the answer. Alright, so this value will be converges at the point pi by 4. Okay, now what is the value of the following series? Okay, so now here I can see that is 1 plus 1 by 2 factorial, 1 by 4 factorial, 1 by 3 5 factorial. So the series, it looks something kind of e to the power x, right? X, we know that x minus x plus 1 x square by 2 factorial plus x to the power 3 by 3 factorial plus x to the power 4 by 4 factorial. Okay, and e to the power minus x equal to same, that is x minus x to the power x square by 2 factorial plus x cube by 3 factorial minus x to the power 4 by 4 factorial, and so on. So this series for the I can see the kind of a similarity, but there is a square outside. So how can I utilize the value of the square? Okay, so now if I just add these two series, e to the power x plus e to the power minus x, okay, so then what will be the value? This value will come, and that is alternative this x square, right? This x square by 2 factorial, x to the power 4 factorial, they will go down. So x plus x cube by 3 factorial plus x to the power 5 by 5 factorial, and there is a 2 factor will be there in the outside. So I should write here 2, and if I divide with 2 in the both side, then this will be x plus x cube by 3 factorial plus x to the power 5 by 5 factorial. I'm sorry, we are doing a lot of screen recording using the screen small. Alright, so x to the power 5 by 5 factorial and so on. Okay, so x plus e to the power minus x by 2, this is nothing but the cos hyperbolic of x. Okay, so if there is cos hyperbolic of x and x equal to 1, if I write, then this will be cos hyperbolic of 1 is equal to 1 plus 1 by 3 factorial plus 1 by 5 factorial, and so on. So you can see that we have found out the value of the right hand side series. Alright, so if we know this right hand side series, then also if we do the inverse thing, that means e to the power x minus, in this case also, if I take the red ink here, so e to the power x minus e to the power minus x by 2, then this value would be x, that should be plus x square by 2 factorial plus x square to the power 4 by 4 factorial, and so on. Okay, so it will be there, and as this is sine hyperbolic of 1, this value will be 1 plus 1 by 2 factorial plus 1 by 4 factorial, and so on. Alright, so now from this equation you can clearly get the idea. So this is basically cos square hyperbolic x minus sine square hyperbolic x. Okay, so cos square hyperbolic x, cos square hyperbolic 1 minus sine square hyperbolic 1, and this value is equal to 1. We know that, right? So this value, option D, is the correct option. Okay, you are getting my point, I guess. Alright, So from where I have understood that this problem will be the hyperbolic, because I can see that this equation, this is a square, and both of the side they have square and the minus, then instantly I have understood this is the basically hyperbolic function. Okay, and that's why I have started from e to the power x to let you show how this function is coming, because I can see that this is a hyperbolic cos hyperbolic 1, and this is basically the sine hyperbolic 1. I can recognize the series, but in order to make you understand, I have done all this thing, and this is why we have worked out this sample problem. All right, now an unbiased die is cast twice. The probability that the positive difference bigger minus smaller between the two numbers is 2. So how can I throw two dice so that the difference between them will be 2? So if one is 3, another is 1 case, 4 2 5 3 6 4. All right, so this is for the first set. Second set I can do this is again 1 3 and 2 4, second 3 5, and third one is the 4 6. All right, so how many point we have in the phase space? 1 2 3 4 5 6 7 8. All right, so now we want to find the probability. So the probability would be 8 by 6 into 6, because we are throwing two dice. So that would be 8 by 36, and this will be 4 by 18, or 2 by 9. Okay, so this will be 2 by 9. That is the answer. Okay, so in this case, this is the answer. All right, so you are getting my point. All right, so now moving on to the next one. For the n cross n matrix consisting of all ones, what is the eigenvalues? All right, so let's say for example take simplest matrix 1 1 1 1. Okay, all the values are 1. So what will be the eigenvalue? So you know that for this matrix we have 0 and 1. This is the eigenvalue. Okay, you can calculate that also. This is not a problem. But also in the case of all 1 for the 3 cross 3 matrix, we know this value, if all the values are 1, then the eigenvalue used to be 0 0 3. Okay, so there is a tendency when you go all the 4 1 2 3 4 1 2 3 4 1 2 3 4, then this value will be 0 0 0 and 4, and so on. Okay, so this is the property of the matrix. You can find it out, and you can just look at this problem, and you can just find out whether if you don't believe it. And so basically this one, which one matching, the eigenvalues are 1 to n, the all eigenvalues 0, all eigenvalues 1 eigenvalue n, all the other. This option is the right option. Okay, so this is the problem number 6 what we have discussed today, and there are 6 problems we have discussed, and I guess you have learned something today. Thank you so much for tuning in, and understand this problem properly. If you have any doubt, just leave one comment down below. I'll attempt all the comment and try to solve you the rest of the problem what you have not understood. Okay, so you have understood that to sit for any this kind of exam like Jest or Jam or the net, what you need to have the basic idea and few series in mind, so that you can just instantly abruptly write down the answer from the options. All right, so let's hope for the best. Tata, and tomorrow we'll solve the next set of problems either from Jest, Jam or CSI net. All right, bye bye.